and I'm very pleased to introduce the first one, which is enabling mass customization of printed sensors by Flexoo, and I'm pleased to introduce Dr. Jean-Nicolas Tisserant.
Thank you. Just a second. How do I change the slides? Where is it? This one here? Perfect. So welcome everybody, good morning. I'm Jean-Nicolas Tisserant, I'm head of development at Flexoo. I'm going to talk today about mass customization, or how to make bespoke solutions ready for mass production. So if you come with your problem, we find the right solution and we bring this solution all the way to mass production. At Flexoo, we sense your need. We specialize into end-to-end solutions for smart sensors and electronics, from initial development to final manufacturing. We have all in-house to fulfill these requirements. This is where my team comes in play. I'm leading a team of 7 engineers. This is the development. We find the best sensor, the best wiring solution, and the best readout electronic for your system. After this, we're able to upscale the production up to some millions of pieces in our in-house roll-to-roll printing machine. And if needed, we have a second roll-to-roll machine 15 kilometers away from the first one, able to produce day and night all your sensors. What is mass customization? So it's the mass production of bespoke sensing solutions. So people come to us with their own problems. They have fixed geometries, they have limitations in temperature and humidity, in terms of use. And what we have developed is the toolkit for allowing mass customization. I'm going to present 2 of these tools today. The first one is a very outstanding sensor to be able to cover all your needs in terms of range, drift, hysteresis. So one sensor to fit most of your applications. This is the first part I'm going to present. The second one is our patented endless connector. So this allows you to address sensor further away from one printing circumference of your printing cylinder. And this allows to have one connector for most applications. What we're talking about are pressure mapping arrays and pressure sensors. These are piezoresistive sensors where you press 2 microstructured surfaces together, and through this pressing, you either increase the number of contact points or increase the surface of these contact points. And this leads to a change in the resistivity. This is then read out by a dedicated readout electronics. They are used in many applications. One I'm showing here is that of battery monitoring. So these piezoresistive sensors are placed in between the cells of the batteries, and you can monitor as a function of time the pressure distribution or the temperature distribution. And this leads to significant improvement in the battery lifetime through limitation of overcharging or excessive pressure or temperature locally. So these pressure mapping arrays are very good at many things, but they are not good for everything. Here are 2 of their limitations. So first, it's very difficult to quantitatively measure pressure due to different factors like crosstalk of the readout, drift of the sensor, hysteresis of the sensor, pixel-to-pixel variation. In the first part of the talk, I'm going to show you our best sensor that solves both drift and hysteresis of these sensors to a very large extent. In the second part of the talk, I will present our endless connector to fit all kinds of geometry. So one sensor to fit them all in terms of range and precision of measurement, and one endless connector to fit all the geometries that you're looking for. And with these 2 tools, we're able to mass customize, to propose a customized solution that we can upscale. So as I mentioned before, when you're pressing these force sensing resistors once against the other, they are microstructured, and you deform these microstructure when you press them. There are two effects. One is the time drift. You are deforming in a viscoelastic